In 2004, NASA unveiled a groundbreaking image known as the Hubble Ultra Deep Field. This mesmerizing snapshot captured a tiny slice of the Fornax constellation and revealed an astonishing 10,000 galaxies. Some of these galaxies date back an incredible 13 billion years, just 800 million years after the universe's explosive birth, the Big Bang. These cosmic images offer scientists a priceless window into the distant past, allowing them to study galaxies at various stages of their evolution. Imagine for a moment a group of extraterrestrial explorers eager to understand human aging. They arrive in their sleek, saucer-shaped spacecraft and decide to photograph everyone in New York City's vibrant Times Square. By capturing a wide array of people at different ages, they gain a unique snapshot that allows them to analyze and gain insights into human life. Similarly, astronomers use the Hubble Ultra Deep Field image to delve into the evolution of galaxies. Despite the vast array of modern telescopes and observatories, astronomers still face numerous questions about how galaxies originated and evolved. Previously, we knew that some of the oldest galaxies formed when the universe was around 1 billion years old. But with the arrival of the James Webb Space Telescope, our understanding has deepened. We now know that galaxies existed when the universe was only 300 million years old, pushing the boundaries of what we thought we knew about cosmic evolution. Despite our advancements, scientists are still grappling with a cosmic mystery that rivals the classic chicken or egg dilemma. Did galaxies or black holes come first? This question has been a major focus for NASA's James Webb Space Telescope. To tackle this conundrum, researchers have turned their attention to a colossal discovery that has intrigued astronomers since 2013. That year, astronomers, using data from the Herschel Space Observatory, made a groundbreaking discovery: the earliest known galaxy actively forming stars. This galaxy, named HFLS3, came with an unexpected twist. Even though the universe was only 850 million years old at the time, HFLS3 was teeming with a remarkable number of new stars, challenging existing theories about galaxy growth. This colossal stellar factory was producing stars at a rate approximately 2,000 times greater than our Milky Way, despite having a similar mass. Astronomers had previously expected that galaxies in the universe's infancy would not reach such immense sizes or exhibit such intense star formation rates. This startling revelation posed a significant challenge to our understanding of galaxy development. Some scientists propose that HFLS3 might not be a single giant starburst galaxy, but rather an interacting system of galaxies, still very bright and bursting with stars, but functioning as a collective rather than as an individual entity. In September 2022, with this new theory in mind, scientists using the James Webb Space Telescope focused on HFLS3's glowing neighborhood. The team from the University of Oxford captured a set of images revealing the galaxy's brightness across various wavelengths and fields of view, shedding new light on this intriguing cosmic puzzle. The team then delved into the intricate details of HFLS3 by analyzing the movements and heating of the galaxy's gases. They also modeled how gravitational lensing might have influenced the light we see. This meticulous work led to a more accurate image of HFLS3. Instead of discovering a single rotating galaxy, as they had anticipated, they uncovered 6 smaller galaxies interacting closely with each other. Given the incredibly dense environment, scientists propose that this sextuplet system is colliding, sparking a dramatic surge in star formation. This groundbreaking observation was part of the James Webb Space Telescope's program called Galaxy Assembly, This ambitious project aimed at 40 of the most distant and massive galaxies, allowing scientists to explore even the smallest details around them. Thanks to these observations, it's clear that HFLS-3 is a colossal structure brimming with new stars, forming from a massive galactic association. Had this been a single giant galaxy, scientists would have needed to rethink their theories, as noted by one of the researchers. Fortunately, Webb's insights have refined our understanding of cosmology, though the age-old question of whether black holes or galaxies came first remains unresolved. Last year, something truly mind-blowing emerged when scientists examined the JWST Advanced Deep Extragalactic Survey (JADES) image, searching for faint galaxies visible in the infrared. To their astonishment, a few enigmatic objects stood out. The data revealed that some young galaxies had powerful cyclones swirling at their centers, an unexpected and incredible finding. Further observations over the following months only heightened the mystery. The most straightforward explanation? Black holes, each with masses equivalent to millions of suns, stirring up gas clouds into a chaotic whirlwind. While finding black holes in the early universe is not entirely surprising, given that the James Webb Space Telescope was designed to uncover ancient objects, the scale of these primordial black holes was astounding. This discovery prompted a flurry of questions. Where did the first supermassive black holes come from? Did they grow at an astonishing rate, or were they born exceptionally large? In their quest to understand the early universe, astronomers have indeed opened a cosmic Pandora's box, revealing a multitude of black holes that could potentially challenge and reshape our established theories about stars, galaxies, and even the Big Bang itself. Indeed, scientists have made a groundbreaking discovery by detecting the oldest black hole ever observed, dating back more than 13 billion years to the very dawn of the universe. The James Webb Space Telescope reveals this ancient black hole nestled at the heart of a galaxy as it appeared just 440 million years after the Big Bang. Astonishingly, this black hole is around 1 million times the mass of our Sun, an unexpectedly huge size for such an early cosmic object. Professor Roberto Maiolino, an astrophysicist at the University of Cambridge who led these observations, expressed that the sheer mass of this black hole was the most surprising element of the discovery. Since black holes don't emit light, astronomers couldn't capture a direct image. Instead, they detected the faint but crucial signatures of its accretion disk, the swirling halo of gas and dust encircling the black hole. Traditionally, it was believed that black holes grew gradually over 13.8 billion years through mergers and the consumption of stars. Yet this gradual accumulation theory struggles to explain the enormous sizes of today's supermassive black holes. The recent observation of the galaxy known as GNZ-11 has pushed the timeline of black hole formation back to their infancy, suggesting that some black holes grew at an astonishing rate during the early universe, much faster than previously thought. This challenges the conventional belief that galaxies formed first, followed by the growth of black holes within them. Instead, primordial black holes might have been woven into the very fabric of the cosmos from the start. Moreover, these early cosmic giants could offer crucial clues about how their massive counterparts, like the supermassive black holes at the centers of galaxies, such as the Milky Way, reached their colossal sizes. Here's hoping this year brings more answers and fewer mysteries. The James Webb Space Telescope continues to dazzle us with its remarkable discoveries, not just of distant galaxies and enigmatic black holes, but also with its recent focus on something truly extraordinary. This time, it has captured a breathtaking revelation. We're all familiar with the stunning auroras, or northern and southern lights, caused by charged particles from the Sun colliding with Earth's atmosphere. These spectacular light shows are usually confined to high latitudes, where our planet's magnetosphere directs these particles toward the poles. However, auroras have also been spotted on other celestial bodies in our solar system, including Jupiter, Saturn, and even the active moons like Enceladus. In these cases, the auroras are likely triggered by charged solar particles bombarding these objects. Hold on tight for a truly astonishing revelation. Using NASA's James Webb Space Telescope, astronomers have uncovered an extraordinary aurora around a failed star known as a brown dwarf, named W1935, located over 40 light-years away from Earth. What makes this discovery so perplexing is that W1935 is surrounded by an aurora despite the absence of nearby stars to provide the charged particles typically needed to ignite such a dazzling display. Brown dwarfs, which are larger than gas giant planets but smaller than stars, form from collapsing clouds of gas and dust, much like stars do. Many brown dwarfs, including W1935, are found in isolation, and they've earned the somewhat unfair nickname of failed stars because they lack the mass to sustain the hydrogen fusion that powers stars during their main sequence. The potential aurora around W1935 was indicated by infrared and solar radiation emissions detected by the James Webb Space Telescope, particularly in relation to methane. On Jupiter and Saturn, methane emissions result from charged particles heating their atmospheres, generating beautiful auroras. The research team hypothesized that a similar mechanism might be at work here. However, the twist came when they discovered that, instead of absorbing light, methane on W1935 was actually emitting a glowing light, which baffled scientists. They were left wondering why this brown dwarf was emitting light when it lacks an external solar wind to trigger its aurora. The team theorizes a few possibilities. There might be an internal process within the brown dwarf providing energy to its atmosphere, or perhaps interstellar plasma is interacting with W1935. Another possibility is that W1935 might not be entirely isolated and could be receiving particles from a nearby active moon. Further observations will help clarify these intriguing phenomena. Auroras have previously been used to explain unusual characteristics of brown dwarfs, such as radio emissions. However, the detection of methane emissions from W1935 is a groundbreaking first, revealing the presence of an aurora around a brown dwarf and opening new avenues to explore the chemistry of such processes beyond our solar system. But wait, there's more. The James Webb Space Telescope has also made a jaw-dropping observation in early 2024, galaxies that look like pickles. For years, astronomers thought that early universe galaxies would resemble orbs or disks, much like many in today's universe. However, the latest images from Webb have upended this notion. It turns out that these ancient galaxies are not only not orb-like, but they also bear an uncanny resemblance to bananas. This surprising discovery is shaking up our understanding of galaxy formation and evolution, showing that the early universe was even more peculiar than we ever imagined. Hold on to your seats, because this next revelation is nothing short of extraordinary. After re-evaluating images of 4,000 newborn galaxies captured by the James Webb Space Telescope, astronomers have stumbled upon a potential game-changer. If these findings are confirmed, they could radically transform our understanding of how galaxies form and expand. This breakthrough might also offer crucial insights into the elusive nature of dark matter, an enigmatic substance believed to make up a significant portion of the universe. Despite these groundbreaking revelations, many astronomers remain skeptical. They note that these findings build upon earlier hints from the Hubble Space Telescope, which also suggested that the earliest galaxies might have had pickle-like shapes. Dr. Alan Dressler from the Carnegie Observatories, a key figure in the development of the James Webb Space Telescope, has expressed caution about these results. Though not directly involved in this study, he highlights the challenges in making precise measurements, especially for distant, faint galaxies. The team used statistical analysis to investigate the three-dimensional shapes of galaxies based on their two-dimensional projections. If these early galaxies were spherical or disc-shaped with random orientations, astronomers would expect to see a mix of round and circular appearances. Instead, they found an unexpected prevalence of shapes resembling cigars and bananas. Dr. Pa, the lead author of the study, noted that these galaxies appeared highly elongated, with some featuring multiple bright clumps arranged like pearls on a necklace. Around 80% of the galaxies in the Cosmic Evolution Early Release Science sample displayed these rare shapes, which are uncommon in the modern universe, but are believed to be the precursors to galaxies like our Milky Way. This suggests that our own galaxy may have gone through a similar phase, once resembling a cigar or surfboard. Today, galaxies are typically categorized into two main types: elliptical clouds and flat, disk-like structures, such as the Milky Way. Back in 1926, Edwin Hubble introduced the Hubble sequence, classifying galaxies into ellipticals, lenticulars, and spirals. A 2010 study using Hubble data found that the galaxy types and shapes 6 billion years ago were significantly different from today. The study showed that peculiar galaxies were more common in the early universe, transforming into normal spirals over the past 6 billion years. This suggests that galaxy collisions and mergers played a significant role in shaping galaxies, even though it was previously thought that mergers had decreased significantly 8 billion years ago. The study also revealed that spiral galaxies are relatively young compared to other types. Fast forward to today, and the James Webb Space Telescope continues to challenge our cosmological models. Its latest findings disrupt the traditional view that galaxies evolved from amorphous structures of primordial hydrogen and helium, with collisions and mergers leading to the formation of disks and spirals. Instead, a recent survey using Webb data identified 873 galaxies with redshifts between 0.5 and 4, ranging from 5 billion to 12 billion years old. Of these, 216 were classified as spirals, with 108 unanimously agreed upon as spiral galaxies. Surprisingly, the fraction of spirals was much higher than expected for redshifts above Z equals 3, around 11.5 billion years ago. This suggests that these early galaxies had already developed spiral shapes less than 2 billion years after the Big Bang, challenging the idea that mergers and collisions were the primary drivers of spiral formation. Other factors likely played a role as well. In summary, the James Webb Space Telescope has once again amazed us by uncovering an aurora around a brown dwarf with no nearby stars. This fascinating discovery challenges our understanding of these isolated objects and opens up new avenues for research. If you enjoyed this video, give it a thumbs up and share your thoughts in the comments section. Don't forget to subscribe for more cosmic discoveries.